Hi, I'm Chris, and in this video we're going to cover a related rates question that one of my calc students had the other day. So here's the problem. Air is being pumped into a spherical balloon at a rate of 5 centimeters cubed per minute. Determine the rate at which the radius is increasing when the diameter of the balloon is 20 centimeters. Okay, so first let's take a look at what values we have. So this is a cubed unit, so that lets us know that we're dealing with volume, and specifically here it's a change in volume. So this is going to be our v prime of t, because it's a change in volume over time. So that value is going to be 5. And then they give us a diameter of 20. So alright, so we have these values. So now let's figure out, okay, well, what are we supposed to do? What equation are we going to use? How are we going to actually solve this? So if we have a v prime, meaning we have a derivative, then that means volume is going to be an equation that we would have to use for this. So let's figure out what our volume equation is for our spherical balloon. So hopefully we remember that the formula for the volume of a sphere would be 4/3 pi r cubed. And in this case, when we take the derivative of that, that's what we're going to incorporate and set equal to 5, because it's the derivative of that equation that's going to give us our value of 5, which is the change in volume per minute as we pump air into this balloon. So the second thing we might notice when we write this down is we might say to ourselves, hey, this formula's got an r in it for radius, but I don't see a d for diameter. So hopefully that's something that we can just make the tiny little leap, little jump, and say, okay, well, if the diameter is 20, then they're talking about a moment when the radius is 10. So then we say, okay, good. Let's work with this and let's ignore this, because I want to try to keep everything in terms of the same variables if possible, so that when I derive, it's a much easier process. So if we take the derivative of this, we get, using power rule, you multiply by 3. So 3 times 4/3 would just be 4 pi r squared. And then we also have to apply chain rule, and this would be times the derivative of r, or times r prime. And so that's what we would have for our derivative function for v prime. And now we can plug in our corresponding values here. So we can say that we have v prime equal to 4 pi times our radius, which, remember, up here was 10 squared, times, now I don't know a change of radius, but that's my only remaining variable. Let me just double check. Let's make sure that's what the question's asking. They want to know, determine the rate at which the radius is increasing. Okay, yeah, so that is correct, that's going to be the variable that we solve for. So we do the math on this, and we do 4 pi times 10 squared. That would be 200 pi, so we would have 5, or sorry, that would be 400 pi times r prime. And then we divide by 400 pi. 5 over 400 can reduce to 1 over 80. So this will be 1 over 80 pi equals r prime. So our radius in this case is going to be increasing at 1 over 80 pi centimeters per minute for this question. So hopefully that makes sense. And if you'd like some more practice, check out our other videos on related rates. Thanks for watching.